When spinning up ephemeral environments for deployment validation, we need to compare three distinct strategies: the shared client SDK approach, custom stubs, and using WireMock. To be clear, when we say stubs in this context, we mean a standalone binary in your ephemeral environment. For example, a lightweight fast API service container where the endpoints are mocked. Let's start with the shared client SDK approach. Sharing common data structures like schemas or DTOs is excellent for keeping provider and consumer synchronized. However, implementing an SDK forces your team to refactor production code base to integrate these proprietary methods. This is fragile. Because the SDK runs inside production code, any bug in its retry logic or thread management risks bringing down your entire service. And that can come from two needs: missing test functionality in SDK and the service itself. The most important rule is to not introduce changes in service if changes come only because tests need additional logic. Furthermore, when you mock an SDK in your tests, you lose the network. You are executing tests in memory, bypassing real serialization, timeouts, and connectivity issues. In contrast, custom stubs or WireMock force your application to execute real HTTP calls, proving your network layer works in reality. Now, while SDKs make running parallel tests easier because they are just code dependencies, so introducing complex logic into an SDK is a massive liability. Because that code lives in production, any mistake is a production incident. Stubs are vastly more flexible. You can easily duplicate or modify endpoints for specific test edge cases without touching your production application code. The most severe drawback of the SDK approach is that it makes ephemeral environments possible only when you run tests. Since the SDK forces you to run dependencies within your test runtime, you cannot easily spin up isolated, on-demand infrastructure. This is where standalone stubs and WireMock completely change the architectural game. Because they are deployed as independent containers, your ephemeral environment becomes a fully functional standalone sandbox. You don't have to be actively running a backend test suite to use them. A front-end developer, a manual QA engineer, or a script using Postman can send real traffic to these environments at any time, exploring the system exactly as they would in production. Furthermore, Stubs and WireMock are completely language agnostic. A shared Java SDK is completely useless if a downstream team decides to write their new service in Python or Go. By moving the mocks out of the application code and down to the network layer, any polyglot service can communicate with them over standard HTTP protocols. This true infrastructure isolation allows you to deploy a complete replica of your microservice topology on demand. Professional QA platform architects resolve most of this by using WireMock or Stubs. To scale this for 200 services, you must establish a strict ownership where code is developed and by who. Usually, dependency provider teams own their mock artifacts. They define WireMock mappings or stubs in version control alongside their production code. On every successful build, the provider's pipeline publishes version test artifacts that other teams can easily download. And to eliminate contract drift, the provider must execute consumer-driven contract tests against their live code before those artifacts are ever published. Thank you for watching. Please subscribe to the channel and leave a like.